Okay, go.
Okay, hi and a very good morning to all. My name is Nur Sarah Farisha and today our group want to perform the assignment task given about torsional loadings evaluation from actual structure. The objectives of this project assignment are to draw detailed FBD from actual structure related to the problems, to develop equation of equilibrium from the free body diagram, and to analyze the force members from the structure. Next.
Okay, thank you, Sarah. My name is Muhammad Amir bin Ibrahim. So, for the introduction, the torsion refers to the twisting of a straight bar when it is loaded by moments or torques that tend to produce rotation about the longitudinal axis of the bar. Its effect is of the primary concern in the design of drive shafts used in vehicles and machinery. And for this reason, it is important to be able to determine the stress and the deformation that occur in the shaft when it is subjected to torsional loads. So this is the spinning wheel parts diagram. Number 1 is track adjustment. Number 2 is bell arm. Number 3 is line roller. Number 4 is spool. Number 5 is the body. Number 6 is the foot. And number 7 is the handle to rotate the engine. So
All
next,
right.
Amar.
Thank you, Muhammad Amir. Alright, I'm Muhammad Amar Bakir bin Zul Nazruddin. I will explain about free body diagram for this project. Let we see at the left of the slide, we can see the free body diagram, which is the dimension for this fishing reel, which is have x, y, and z axis, and the dimension, the length of the fishing reel, which is 139 millimeter. 137 millimeters, and the force which is applied to the handle 150 newton, and then based on free body diagram that we have made, we can develop equilibrium equation, which is we got the equation positive clockwise summation of moment is equal to 0. And then from this FBD also, we can analyze how many members, how many force members at this FBD. So one more thing, the angle of twisted fishing reel is 45 degree, and the diameter for the fishing reel is 0.005 meter. That's all for me, and I call Sarah to continue.
Okay, thank you, Alma. As you can see here, this is the table of the mechanical properties of aluminium. We have the metric value of ultimate tensile strength, tensile yield strength, shear strength, fatigue strength, modulus of elasticity, and also shear modulus. This table helps in our calculation soon. So let's proceed to the calculation part. Firstly, we use aluminium as the material for our fishing reel or spinning reel. And referring to the table just now, the shear modulus is 26 gigapascal. For EOE, we assume it is positive clockwise since there is an angle of twist, so the formula is T is equals to FD sine theta. We substitute the applied force, which is 150 Newton, times with the distance or length 0.137 meter, times with sine 45, and we can get the internal torque is 14.53 Newton meter. Next, for the polar moment of inertia, the formula is J is equals to pi over 2 power of 4, The diameter is 0.05 meters, so we can get the polar moment of inertia is equals to 9.82 to the power of negative 10 unit m power of 4. To gain the maximum shear stress, we substitute the value into the formula T times with C over J and get 73.98 megapascal. As for the factor of safety, we calculate tau fail 0.5 multiply with the tensile yield strength 276 megapascal and get 138 megapascal. Tau allow is same as summation of tau maximum, so the value is 73.98 megapascal. Now we can determine the safety factor by dividing those two values and give the value of 1.86. Next.
Thank you, Sarah. It's Rafara Fariza, and I'm going to explain about discussion based on our project. Mechanism of the top depending as the moment of the twisting structure. Axial load which produce a uniform or average stress over the cross-section of the object, and a torque create a distribution of stress over the cross-section. When torque is applied to the structure, it will twist along the axis, the larger the shear strength. Since twist applies a shear strength, we expected the torque will apply a shear stress. Based on our project, factor of safety can be calculated by using max torque divided by actual torque. Since the value of our project is 1.86, it can be stated that the fishing reel is safe while being used. That's all.
And okay, next I want to conclude about this assignment. So from this assignment, we gain a lot of knowledge on how to construct the free body diagram based on actual structure. Our group decided to choose fishing reel, then determine the structure of the fishing reel by measuring the fishing reel and the normal force. We applied all the theory and using the formula to calculate the problem. We also be able to calculate the maximum force for the fishing reel to achieve failure and demonstrate the working principle of the system. So that's all from our group. Thank you.